Most of us go through life assuming there simply isn't enough to go around. We look at the world and see finite land, a limited energy supply, and a fixed amount of food. When you assume resources are strictly limited, human behavior locks into a zero-sum loop. Every time someone gains a plot of land or a barrel of oil, the math dictates that someone else has to lose it. Our global political and economic infrastructure is built squarely on this assumption. Nations draw borders, build militaries, and draft treaties primarily to secure their piece of a shrinking pie. As long as the baseline equation requires someone to lose for you to survive, global conflict is a mathematical certainty. The problem cannot be solved from within that framework. In the mid-20th century, a polymath named Buckminster Fuller noticed an anomaly in that equation. Through a careful inventory of global resources and industrial capacity, he found that humanity had actually crossed a hidden technological threshold. We had developed the capability to generate a physical surplus for every human on Earth. We possessed the tools to feed, house, and connect everyone, yet we continue to fight over resources out of deeply ingrained habit. We were holding a winning hand, but we were still playing by the old rules. This meant the persistent poverty and starvation across the globe were no longer caused by a lack of raw materials. They were strictly the result of a failure in design. We are currently trying to pilot a highly complex, interconnected planetary spaceship using the obsolete operating manual of a primitive rowboat. To write a new manual, Fuller relied on general systems theory. This is a problem-solving approach that requires stepping back from the narrow focus of isolated specialists and examining the behavior of the whole structure first. To understand our true constraints, we establish an absolute boundary. We must view the entire planet as a single closed system floating in space. This diagram illustrates how human beings process reality within that system. On the left side, the physical brain functions as biological hardware, taking in isolated sensory data points, like the physical edges of wood. On the right, the metaphysical mind discovers invisible, eternal principles, like gravity or wave frequencies, that cannot be seen directly. When the mind applies these eternal principles to our finite physical elements, it can rearrange them into highly efficient structures that the biological brain could never have predicted from the raw materials alone. Because the brain only sees immediate physical limits, it defaults to panic. The metaphysical mind is the only mechanism we have capable of overriding that biological fear and engineering a way out. Fuller called this process ephemeralization. Ephemeralization is the technological ability to achieve exponentially greater outputs using fewer physical resources through applied design. For decades, the historical baseline for global communication required massive, heavy physical infrastructure, like this multi-layered transoceanic copper cable. This scale graphic visualizes that immense physical burden. To connect continents by voice, humanity laid down 175,000 tons of physical copper mass across the ocean floor. But by applying orbital mechanics, we built a quarter-ton communication satellite that outperforms the entire 175,000-ton copper network. We extracted identical performance while eliminating 99.9% of the required material. This specific data point proves that intelligent design can outright defeat physical scarcity in the real world. These technological leaps expand the mathematical limits of the Earth's carrying capacity, allowing finite materials to support an exponentially larger population. Humanity now faces a critical threshold with two clear paths. We either continue fighting bloody conflicts over perceived scarcity, or we commit to a peaceful design revolution. Traditional politics has largely failed to solve this because it relies on attempting to force humans to be good, asking them to altruistically share scraps from a pie they believe is shrinking. The necessary alternative to this political coercion is what Fuller called anticipatory design science. Anticipatory design science is the practice of identifying future problems and creating physical tools to solve them before they cause societal breakdown. Instead of passing laws demanding people behave better, anticipatory design works by building physical artifacts and systems that make cooperation and mutual success the most logical, effortless path for everyone to take. This requires us to stop looking at the universe as a decaying, finite trap. Physics tells us that energy is never lost. only transformed, meaning we live inside an infinitely regenerative, perpetual motion system. Engineering for total abundance is a viable outcome that becomes accessible as soon as we move beyond localized competition to operate as designers for the whole system.